Good evening, students. Today we are going to solve this AS level past paper physics question. I think you might see in that question, in some other websites also and some other videos also, but I will give you some exciting calculation method here in this video, because while solving that question I was very impressed, and immediately I have decided that I should definitely give an video, and this would be a best video because that question is a worthy one, and it has given me a lots and lots of idea, and as well as it has given me a lots and lots of excitement. I just thought out of box, and it just created that creative power. So it is actually we can get more, that is we can learn more things by solving this type of question. So definitely you should practice that question. Just pause the video and practice that question. After that, please see that, see the answer, that is, see the calculated way what I have shown in that one. Okay, let us solve this one. So one plank has been placed, though, so that plank should not, that is that resultant force should be zero, right? Because the plank should be in equilibrium. If any force is exceeded, that is clockwise force and anti-clockwise force. If any force or any moments, it's not like that force, any moments exceeded, what will happen? The equilibrium will be disturbed. That is why for we are applying that principle of moments for that plank at equilibrium, right? Okay, so they have placed that a plank here, but the mass should be concentrated at the center, right? Because the center of mass will be concentrated at the center. That is why they have applied that force. That is, they are showing that force at the middle, right? Because of the mass, there will be a force that is called mg. That force has been shown at the center because the center of mass will be here. So what is the center of mass? Overall mass will be concentrated at the middle for a rod, long rod. The overall mass will be concentrated at the middle. So the force created by that mass has been mentioned at the center, and the force created by the man has been shown uh, at the uh, at where he stands. Okay, so this is the difference between the center of mass and normal mass. Okay, then shall we go to that question part? Yeah, let us explain that one. Explain why sum of forces Fa and Fb is constant. Look at this. Actually, if you are increasing Fa, that is the force on the A end, if you are increasing that one, automatically Fb gets decreased and the resultant force becomes zero. So then again, if you are in decreasing that Fa, Fb will get increased. So Fa and Fb will always be constant. So the resultant force will be zero because the Planck is at equilibrium. So what is the meaning for equilibrium? The resultant force should be zero. The upward force, that is the clockwise moments, and the anti-clockwise moment should be equal. That is why the resultant force will be zero. That is then that is the equilibrium condition. Okay. Uh, Even now we are not at all in the interesting part. We are going to solve that second part, and we are going to get some excitement here. Trust me. Okay, look at this. I'm going to show that diagram here, and one mass has been concentrated at this place, and then it is at 2.5 distance from the end A, and then 2.5 distance from the end B. Overall 5 meter they have given. So why I am showing that in a different, that is why I have separated that distance, because the considerable point is here. A and B are the considerable point. This is not a considerable point. This is not a considerable point. But in the theoretical part, you may learnt like that, right? Theoretical point, the upward force will be like that, the downward force will be like that. This is will be this d1, this will be d2, and this will be f2 and this will be f1. The principle of momentum will be, moments will be f1 d1 is equal to f2 d2, like that you have learned in your theoretical way, like that. So in your subconscious mind you may think this is a considerable point, this is not a considerable point, this is the considerable point. Actually the moment should be applied here. The considerable point here in the theoretical part will be this one. The equilibrium will be at this position, but here the equilibrium will be at this position or this position. At any position that will be an equilibrium, right? So that is, in both position there should be an equilibrium. So take that considerable point like that. Think about that, why we are taking that as a considerable point, because the force, that is the moment, should be equal at that position only, then only the Planck will maintain the equilibrium. If the moment is at the center, that is if the moment has been uh, principle of moments has been applied at the center, means what will happen, that Planck, overall Planck will not be in equilibrium. So both the n should be in equilibrium, means equilibrium should be in equilibrium means the principle of moments should be applied at A and B. So I'm going to apply the principle of moments at A, and look at this. Here one man stands. Uh, then how we can apply the principle of moments to get that FB? Look at this. FB is in the upward direction and FA is also in the upward direction. Okay, let us consider that FB. Okay, look at this. So according to the principle, that is principle of moments, we can consider any point. So I'm going to consider first FA. Okay, so FA, look at this. So with respect to FA, this is a clockwise force. This is also a clockwise force. And this FB is an anti-clockwise force. So the clockwise moments and anti-clockwise moments both will be cancelled at the, according to principle of moments, right? So I'm going to apply that anti-clockwise moments. There are two clockwise moments and anti-clockwise moment is one. So clockwise moment I have taken, that is F into D. So clockwise moment means 880, and the distance that what they have given is 0.5 meter, right? 880 into 0.5, and then 200, both are clockwise. That is why I have added that one. 200 into 2.5. And then that will be equal to FB, and the distance between this considerable point from here to here will be 5. So if you are cancelling that one, you can get easily FB, that is 188 Newton you will get. Please calculate that one and confirm me in the comment box, or in my or just message me to my WhatsApp number. Okay, then the next thing, shall I apply the same thing for the end B? Because I have considered that A, right? Now I'm going to consider that B end. Why we should not consider that B end? So look at this. If I'm considering that B end, the principle of moments, how it will play, that will be very interesting. Come on, this is an interesting part. Now that two forces are in anti-clockwise direction according to that considerable point, and this force will be clockwise direction. And this force we could not take that for a moment, because if you are considering that point, distance is 0, so that moment will cancel here. So not necessary to consider that FB, because the FB into 0, then there will be 0, right? So if you are applying that same principle of moments at that point, then it will be FA, that is clockwise moments. Clockwise moment will be FA into 5, and then that will be equal to anti-clockwise moments, that is 200 into 2.5, one anti-clockwise moment, and then 800 into, sorry, 880 into, what is that, 880 from this point to this point, what is the distance? It will be 2.5 and then 1.5. It will be 4, right? So 880 into 4. Then I will get that force. Okay, let us calculate that one. 880 into 4. That will be 3520 plus 500 divided by 5, 804. I'm getting FA as 804. If they are asking FA, then take the considerable point B. Okay. The considerable point B means we will get FA because the distance from B to FB force will be 0. Like that. Here, why FA has been cancelled in that first case? Because the distance between the considerable point and FA force will be 0. That is why we can able to calculate. That is, we, we can able to calculate that FB. Okay, then we will go to that next part. Look at this. I got 804, right? I have checked that one. If x is zero point 0.5. So what is that 0.5? So actually x is 0.5, right? So 0.5 means 1. Uh, so this will be the 0.5, right? So 0.5. So in that 0.5, I'm going to connect that zero point 0.5 to that position. Okay, let us calculate whether we are getting 804. Let us do that. Look at this: 550, 600, 650, 700, 750, 800. Yes, we are getting that 804. That's what I said. So out of the box, I have calculated, that is, I have calculated that principle of moments to that A and I have checked the graph and I got the exact value. That is the excitement what I got. Okay, then let us solve this one. So what they are asking, sketch a graph to show the variation of X of force FB. Okay. So here they have shown FA, right? Now I'm going to show that FB. So FB with respect to X. First I'm going to take that X as 0. So X as 0 means what will happen? Look at this, X as 0. Then FB will be, that is FB, the considerable point now is A, right? So FB into 5, that will be equal to 880. So X is 0. I'm going to take that X as a 0. So 880. So I'm going to consider that point, which one? Okay, I'm sorry. Actually, I have to consider that point. If you want to calculate FB, you have to consider that point A, right? So X is 0 means 880 into 0. Okay. And then 200 into 2.5. So what we will get? 500. FB will be 500 divided by 500. So 100, it will be 100. Okay. 100 may be here, right? So I'm going to take that 100 here. And then already we have calculated X is 0.5 means what is that? 188. So another 1 point I'm going to take here. So what we are getting? We are getting the straight line with the positive slope. That's all. We are getting the straight line with the positive slope. But in the case of FA, we are getting the slope with, that is, we are getting the straight line with the negative slope. So here the slope will be negative, here the slope will be positive. So FA and FB both are having opposite moments. That's what I got from that question. You also please enjoy that one. Thank you.